Alright, so this is one that you were doing yesterday. You may not have got there. If you didn't, it is okay.
I have your page in my book.
No worries, I will get you the new book shortly, okay? First one. 7x cubed minus 12x plus 5 equals 4x cubed. What type of equation is this?
Cubic.
Okay, it looks like a cubic.
This is a new one that we have to do?
No, we're just going to work through this together. This is from yesterday. Okay, it doesn't look very nice because it is a cubic. What am I going to do? Am I going to what's the first thing I'm going to do? Okay, you don't need to write it down if you don't want. That's okay. Zavi?
You're going to want to move all the x's to one side.
Okay.
So you take the 5 over.
Right.
So subtract 5 from both sides.
Okay. Is there anything I can do before that? There's always something I want to try and do before I collect, before I. Okay. Maya, tell us.
You have to
Collect like terms. Okay. Specifically.
So the 4x to the
Yeah, the 4x and the 3x here. Okay. So this side says the same. 7x cubed minus 12x plus 5 equals 4x cubed plus 3x cubed.
7x.
Good. Plus 9x minus 11. Now I can, Zavi?
Move all of the x's to one side.
Yep, and the 7x cubed. So I'm going to bring the 7x cubes all together. So if I'm going to do that, how do I get rid of this, Brandon, on this side?
You
Oh, I add or subtract it? Subtract it because it is being added at the minute. Now the nice thing about this is, what happens?
Zero.
Yeah, I end up with 0x cubed. Do I need to write down 0x cubed?
No.
No. So what type of equation actually is this?
Now it's a linear.
It's actually a linear equation, yeah. So I've got minus 12x plus 5 equals 9x minus 11. Our next step, if I want to get all my x's together, hands. 1, 2, 3, 3 hands. 4. Lela. I can do that, that's fine. So on the left hand side, more hands. Bella.
-21.
I can't see that. Negative 21x plus 5 equals 11.
-11.
Oh, sorry, thank you very much. I know. Minus equals negative 11. Okay. Just shows, all the greats make mistakes too. That happens. Is this correct? Is this correct?
Yeah.
Minus 16 over minus 21, which is. Alright, okay, good. So, even though it may look nasty, these equations often turn out to be actually quite nice, okay? So, do not let it. The smiley face, obviously, okay? Even though it may look not very nice, okay? You just work through, you don't panic, you take your time, and you will get to where you need to go, okay?
So is that whole equation, now that we know that it's turned out to be the final linear, does that mean the whole equation is linear even though it starts out?
See, that's a good question, and that's actually, I do want to give you a wrong answer here, because that's something I would want to check up on. As it's written, it is cubic, okay? But when we come to solve it, it actually turns out to be a linear. So I would argue that this is a cubic equation. I would argue that it's cubic.
There's only one final answer.
There is.
You could make it.
Okay. But it is a good question, but I'm going to defer on giving you a solid answer for I will go and have a look. I think there's different schools of thought on yeah, we'll come back to that in a second. Right, we're going to have a look at the following. I have this print it out for you, so you don't need to write it down. Do not write it down. I have it. You're going to work through this. Okay? You're going to. Yep. This is probably the last bit of graphing you're going to do. Okay? So you're going to find out where these lines intersect, and then we're going to. We're going to work through these, and we'll do it on decimals as well. So you've all drawn these. It all looks pretty nice, and you should get. Boom. Okay, there is our y equals negative 3x plus 1. Here is our y equals 2x minus 4. Did you all get the intersect where they cross at 1, negative 2? Okay, right. So the question says, the next question, number 2, why do these lines intersect? Okay, now I'm not looking for anything too fancy here, but Sam, why do these two lines intersect?
Because one equation has a positive gradient and the other has a negative gradient.
Right, one has a positive gradient and one is a negative gradient. If I want to put it in even less maths terms, what am I saying here, Bella?
One's sloping, one is sloping down and one is sloping up.
One line is sloping down, one line is sloping up, okay? So that means at some point they are going to intersect, okay? Doesn't matter, like if one line is sloping up, one line is sloping down, they are always going to intersect, okay? So that would be fine for this part of the question. To justify it mathematically, we would then start to talk about gradient, and we would say, what? Again, it's nothing too complicated, Sienna?
Because the gradient on, like, the gradients, one of the gradients
Yep.
is positive and one of them isn't.
Right, one of the gradients is positive, so the line is sloping up. The other gradient is negative, which indicates the line is sloping down. Okay? Does that make sense?
Yeah. Yes.
Just remind me, how would, if we had two equations, when would we know that they both definitely do not intersect? When's the only case when they do not intersect? When they're parallel, right? Okay, when they are parallel. That means that they have the same slope or same gradient. Right, so we found our point of intersection. What did we say it was? 1, negative 2? Everybody's cool with that? Okay, now this is where we're going to start doing it more algebraically. Okay? We want to verify this point of intersection by substituting the coordinates of this point into the original equation. So, I think some of you may have solved this, which is fine. Can you tell me what you're doing, Bella?
Oh, I didn't actually start. Well, what I would do is, so the equation is, we're going to do it.
Yep.
Y equals 2x minus 4.
Yep.
So you know that the 1 is x, so
Yep.
you put the 1 where x is, so
Yep.
it would be 2 times 1.
Yep.
And then you know that negative 2 is y, so you know that the y is negative 2. So it's negative 2 equals 2 times 1 minus 4.
Which equals? Yeah. So we've shown that both sides equal each other. Okay, so that works. And then you have to do that for negative 2 take away 4, negative 2. And then you have to do it with this equation as well, okay? So that shows that that point lies on both lines. Okay, we're not going to worry about question 6.
You write it down. And you write it.
So those two equations for y equals. Y equals. Okay. I will give you just a minute. It's the important part. So what we've got here, we have our two equations, yes? We've got two equations, And how many unknowns? 2, okay? We've got x and y, okay? 2 unknowns. And this is called, these two equations we can refer to as a system of equations.
Can we try this?
Not just yet, I want everybody just to watch, okay? I'll leave it up on the board, okay? Now, you have already solved this graphically, okay? You solved graphically, which was good, you did it quick, and found, that's fine. You solved graphically and found that x is equal to 1 and y is equal to? Okay, right. Alright. We can also do this algebraically. Now there's 2 methods for this. And the first one is by substitution. Okay? Right, so we've got our 2 equations, y equals 2x minus 4, y equals 3x minus 1. I'm going to just write them out again, because I want you to notice something. Y equals 2x minus 4. Right, if y equals 2x minus 4, and if y equals minus 3x plus 1, what can you tell me that 2x minus 4 equals? Right, good, yeah, negative 3x. Negative 3x plus 1. Okay? 2x minus 4 equals y. Y also equals minus 3x plus 1. So these 2 things have to equal each other. Does that make sense to everyone? It's kind of like saying if A equals B and B equals C, then what does A equal? C, okay? Because they're all equal to equal. A equals B, B equals C, so A equals C, okay? Is that okay?
Yeah.
Right, so what have we got here? We now have an equation which we can solve. How would we go about solving this? Oh, come on, you were doing these yesterday. Even harder ones than this. First step, Zuri? Yep. The x's, or do you want to get rid of the number first? Sorry. Okay, so we can get rid of this number here on this side, and I can add 4. Now remembering there's different ways we can do it. This is a good way. So I end up with 2x equals minus 3x plus 1. What's our next step?
Plus 5.
Oh, dear. Letting myself die. Okay, next step. Sam?
Can we move the negative 3x?
Right, okay, but we
Add 3x.
add 3x to both sides. So I end up with, on the left hand side, shout out,
5x.
equals,
5.
so x equals. Right, okay, so we've got our x equals 1, which is what we find algebraically. How do you think then we find out what y is?
Substitute the x.
Right, we substitute it where, Zavi?
For the x. So
Into where though?
like y equals 2 times 1.
Right, good. So substitute back into
And then,
one of the original equations.
and then y equals negative 3 plus 1.
Right, okay, so I've got y equals 2x minus 4. Y equals 2 times 1 minus 4. So that's 2 minus 4, so it is negative 2. So our point of intersection, we've done it algebraically, is 1, negative 2.
It's
Okay?
like a justification.
It's a justification for your graphical method, which is, yeah, that's good. Now, if you're given a question like this in an exam or anything, and you're asked to solve 2 equations like this, You could do it any way you want, okay? But doing it algebraically is a lot quicker and easier, okay? Rather than having to draw stuff. Sorry? Probably this one, because if you're doing it graphically, you're going to spend a lot of time doing it and making sure you get it right, and so you're going to waste a lot of time, okay? Right, so can we? Whereabouts do we need? Can I put it down to here? And if we can get all of this down, please. This is the last bit of writing. I'm going to make you do it, so we're going to write. And we solve a system of equations. Solving two equations here essentially at the same time. Yes, we are solving simultaneous or simultaneous equations. We're solving two equations at the same time, yes.
Good morning, Miss Emma.
Okay, let's look at those. Can I move it to, does everybody have all the stuff from the top? No, or what?
Wait, oh, you mean the top?
Yeah, yeah. Has everybody got everything? Is that okay to put it there?